Hey guys, gonna do our final video on astronomy. We're gonna be talking about stars and massive stars and the end of the lives of massive stars, and then what they become. So, first off, the size of a star depends on two factors. The amount of explosions or fusions that are happening in the center of the star, right? And we can think of those like as atomic bombs because it is really the same thing. A hydrogen bomb exploding creates a lot of outward force, and that's caused by fusion. What's happening inside of a star? The same process, fusion. So there's this outward explosion that's always happening inside of a star, which pushes the outside gas part of the star to be outward, right? At the same time, gravity is constantly trying to fight against that, which gives a star its size, right? Now, when we have a balance of forces, we have this thing called equilibrium. So, equilibrium is a balance. A state of equilibrium is when one thing equally contacts the other and causes a balance. So that's what gives us the size of a star. As a star begins to die, the core begins to collapse, where stronger fusion is going to occur. So that creates a bigger outward explosion, which makes stars grow at the end of their lives because gravity has to fight even harder against that fusion, but it can't. So the fusion ends up taking over and making the star grow even larger. So what's at the center of massive stars? The most stable element, which is iron. Fe stands for iron. Iron is the most stable element. So when a massive star enters the final phase of its life, its center of its core is iron, all right? What does a massive star look like? A massive star is kind of like an onion, right? So this onion effect is just the layering of different elements based on density. And in the center, we have this iron and nickel core near the end of a massive star's life. Okay, so at each one of these layers, we have new fusion occurring, new fusion, and we start making different elements based on that. So if you ever wanted to wonder what the inside of a star looks like, it has to do with fusion. How do we know this? How do we know these different elements are in there? We can measure the light that is given off by a star, and each one of these elements has its own fingerprint. So it has these little slits of light that are missing, different colors that are missing, and each star has its own, each element has its own fingerprint. So based on that fingerprint and based on the light given off by the star, we could tell what's in there, okay? So the end of a star's life. A massive star ends up, the core begins to collapse in on itself, all right? So as that core begins to collapse in on itself, fusion continues to occur, and we end up creating a huge amount of outward motion, and that's called a supernova. So a supernova happens about once every 100 years in the Milky Way galaxy. Ancient Chinese astronomers observed a supernova, and what it looked like to them, even though it was really, really far away, it looked like something as bright as the moon. And it's just a dot in the sky that exists there for a few weeks. So supernova leads to two different things. When a supermassive star explodes, it can form into a neutron star or a black hole. So neutron stars usually form from not so massive stars. Like they're not huge, the biggest, but they are really, really big stars. Like between 8 to 10 times larger than the sun, I believe. So when these stars explode, their cores of iron begin to collapse in on themselves, and the protons and electrons of that iron end up breaking the strong and weak forces which are inside atoms to form into neutrons. These neutrons are able to collect onto themselves, and you can have a neutron, like let's say we had a neutron star the size of a marble, it would weigh about the same amount as the Empire State Building. Think about that. That's how dense a neutron star is. When we have extremely huge stars that explode and go supernova, they form into black holes, which literally means that there's so much energy being produced by that star when it collapses inward that it tears through space. It literally cuts through space and makes a hole in space-time, which is called a singularity. Just like how the universe formed as a singularity, our most giant events of supernova form singularities, or what we think are singularities, which is an infinitesimally small point with infinite density and infinite gravity at its center. So black holes have infinite gravity, and they have so much gravity that the light that tries to escape a black hole gets bent right back around and brought back to its center, which makes it literally the darkest thing ever. It is a complete absence of light. It is completely invisible. It is total blackness. Okay? So Einstein thought of what black holes are. Feel free to go through these videos. They're really cool. They talk about how light is bent through space. And Einstein just thought, you know what, if space is made of space-time, which is like a fabric, and it can be bent so much that it creates a black hole, a space where light cannot escape out. Why are black holes black? Because they literally warp space. All right, so types of black holes. There's stellar black holes, which form from supernova. There's supermassive black holes, which exist from the first generations of stars that exploded, and that's really where our galaxies orbit around. So in the center of all of our galaxies, we have these supermassive black holes, which are insanely huge, like dramatically huge. Watch the video that I put on last week's PowerPoint. And then there's miniature black holes, which are theorized. You know, we haven't seen them, but based on the Big Bang and the theory of the Big Bang and the theory of inflation, we think miniature black holes exist. So some fascinating things. You can stop watching the video now, but here's some weird things. We're humans, and we're made of elements, all right? So the entire universe is made of elements. So the universe is really just elements, space, and time. It's really all it is, and like dark matter and dark energy, which we really don't know anything about. But if the universe is made of matter, and we're made of matter, then we can see the universe. And since we are part of the universe, that means the universe can see itself. So since we are part of the universe, we can see the universe. It's just crazy. All right, crazy stuff. Okay. Take it easy. Enjoy.